Great, great. I want to thank the people here at Robotdalen for inviting me here. This is the first time I've been here, and I'm very interested in the technologies and the people that I've met so far. I want to thank Eric Lindquist. I want to thank Leonard Carlson and Jessica Carlson for helping me arrange the trip here and to putting up with me as I made my way here from Boston yesterday. So what I'm going to do in the next 20 minutes is to give an overview as quickly as I can on the complete robotics industry. Where are we now? I titled that after a song from the latest David Bowie album because he's sort of in a midlife or a little bit further than that along in his career. And in fact, robotics is very similar in that sense. It's one of the few areas of technology that is extremely immature, yet at the same time have been around since the 1960s. So when you say, well, how do you classify this? Well, it's classified as emerging technologies, it's classified as mature technologies at the same time. So given the fact I want to do this in 20 minutes, let's get started. So I initially want to talk about the four subjects here. Where are we right now with respect to robotics? What are these enablers? What can we expect in the near term? And then finally, the visionary stuff, which I'll have in 2 slides. So what's the current state of the robotics industry? Well, before we talk about the current state, I'd like to provide a taxonomic framework for this industry. Now, when I was told I was speaking here, there'd be some people who were maybe not up to speed in terms of where the robotics industry is right now. Other people are experts in the robotics industry, so I try to provide a little of everything. So I apologize if you've maybe seen some taxonomy like this before. I doubly apologize if some of the stuff gets a little bit technical. So I'm kind of stuck in the middle here. But really, the marketplace has been broken down historically into 3 different groups. Looks like we're cut off a little bit. The industrial robotics sector, the service robotics sector, and then the personal or consumer robotics sector. The uppermost one is a mature marketplace, around $25 billion at this time. That's not a whole lot of money. I mean, that's only $25 billion compared to, say, healthcare, $2.2 trillion, I think, worldwide, or manufacturing, which is a very large marketplace. And then you see the service robotic stuff, robots, they're in the semi-structured environments. They're maybe not in a structured manufacturing environment, but they're linked into things such as the healthcare marketplace in the US, 2.2 trillion. You can convert that to euros. It's a big number. Security and defense are the same thing. And then down here is the early adopter stage, the personal robots. These are robots purchased by individuals, typically for use in the home. Another way to look at this, you'll see sometimes we'll break it down into 2 marketplaces, industrial and then service. Again, here's our professional service robotics with service and field robotics, health robotics, domestic robots, which are used, again, mostly in the home or by individuals. And then another area called research robotics, which focus on educational robotics and robots that are used for primary journal-based research. Now, in the previous slide, when I gave the outline in the taxonomy of the research marketplace, I said that's only the beginning, and that's right. We'll get back to that on the last slide. So, industrial robotics sector. Right now, it's moving in a number of different ways. We have more traditional arc welding systems. The emphasis now on the largest component of the manufacturing industrial sector is materials handling. There's an example of it here. They moved into 2 new vertical marketplaces, such as food handling with robotics, so the robots can be cleaned with caustic chemicals and heated to very high temperatures. Assembly robots now moving down to assemble smaller items, so more consumer class assembly and manufacturing, palletizing systems, and now warehouse automation systems that you see. We saw some of them yesterday at ABB, and they're located throughout the world. These are vision-based systems. None of these things are running along tracks, and it's no planned path. I promise not to go through too many of these slides. So basically, the marketplace after the recession is on a huge upswing. 2011 was the fastest growth since 1961, according to robotics. The number of robots worldwide, industrial robots, there's around 1.3, 1.4 million at this time. But where are they going now? You have an industry that's been limited to a large degree to the automotive sector. And for their own protection as companies, they need to branch out from there. So they need to move into other types of marketplaces. So what can we do outside automotive manufacturing or electronics manufacturing? So they've gone in a number of different ways. They've expanded the base to move into non-traditional vertical market segments. You see an example over here of something in the food industry. It's cut off a little bit, but actually that's cutting a hog in half. We have, they've moved into small to medium-sized enterprises to do things like fine assembly. On the upper right-hand side, there's a Denso robot. That's actually putting together cosmetic cases. So again, vision-based. This is a vision-based system, very, very fine manipulation. Trying to do lower cost pricing, and they bundle things together. So again, they're moving out into new marketplaces, and certainly with geographic expansion, typically in Southeast Asia, as well as Asia proper. Adding things such as fine manipulation, vision-based systems, sensing, and then now mobile manipulation. And now we've moved into a new class of robots as you try to move into, say, the small to medium manufacturers. A vastly underserved marketplace. I mean, typically, even when these companies go into new vertical market segments, they're typically with big companies. But in total, in aggregate, it's the small to medium manufacturers, which are in fact a larger part of the industry. So now we've come out with a number of different systems. The names are cut off here. This is Kawada in the middle. Kawada's Cobot. People might be aware of ABB's Frida systems. Rethink's Robotics Bacter, which was launched last November. And off to the left-hand side, I believe that's Universal Robot Systems. Again, you'll notice that the form factor is very similar. It almost looks human. They're dual-armed. Many of them are designed to work in close approximation with people, be very, very easy to program, and very low cost in order to get these into new types of marketplaces. So new class of systems for new types of manufacturing. Typically, a small to medium enterprise, they might not even know what they're manufacturing, and they certainly don't know how many they are, and they have rapid turnover in terms of what they're producing. So it's very different than the automotive or electronics manufacturing industry. Another class of systems here would be these new mobile platforms. So again, we have tugs. We have one from Adept. Here's the Sigrid Systems. I apologize for this being cut off here, but you can see up in the right-hand side, that's Kiva Systems, warehouse automation systems, a very well-known system, largely because Amazon, who funded that through Jeff Bezos's funding wing, went out and purchased it for $750 million, just north of that last year. So this finally woke up the investors in Silicon Valley who now realize that robotics has arrived. This individual tried to get funding in the Valley and couldn't do it, had to move to the Boston area to get that done, but it was invested by in Amazon. So they're looking now to take Amazon, for example, to give you same-day delivery as packages, and this is the way that they can do it in a way that where they can make money. So again, you can see, just literally hundreds of robots moving out throughout a warehouse. That might be Zappos, or it might be another place here. And they just actually pick up the material and bring them to people who pick them and then put them in trucks. So past the industrial sector, let's move into the professional service sector, or just the service sector in general. You reach a point where if you're going to taxonomize this marketplace, it's very, very difficult because the way I describe it is more than stars in the sky. We're actually kind of missing part of the presentation up here. But there's just many classes of these types of robotics products. So let's take a look. Yeah. So again, if you look at the sales here, it was interesting talking to the people at Robotdalen yesterday where they're focusing on. So they're focusing on field robotics, manufacturing, and healthcare. You can see here that outside of defense, they decided not to move there. Field robotics is the next largest one. Logistics, which also includes hospital logistics, is another large one, as well as a medical. So they picked outside of defense the right marketplaces. And examples of these things here, this is the defense industry. So I know that Robotdalen isn't focused by defense, but the point here to be made is that these were funded, and now that defense spending, at least in the US, is tapering down, and these are now being repurposed in whole new ways, commercial ways and humanitarian ways. And we'll talk about that in the next slide. So again, well-funded, literally unlimited amounts of money, moving in now into the commercial space. So examples of this, so to move into things such as environmental monitoring or infrastructure analysis, search and rescue robots. It's very telling, for example, in the Fukushima disaster in Japan. Here you have a country, Japan, well known for robotics. You really have to commend them on the beauty of their design, the elegance of the vision. The engineering, of course, is fine. But when that happened, they didn't have robots that they could use in order to go in and to monitor the situation. And they ended up using military robots, military class robots from the United States that have been proven in the field. We know that they work. They're very robust. And that's telling. So again, I commend on the vision and the engineering. But at some point, you need robots that can actually do important things. It's another example of where they're going. I put this picture in there only because it's kind of scary a little bit. But they're actually testing uniforms here with this particular thing. And this robot's not being held up at all. It's actually just walking along. And that's only for the case where it actually will fall down onto it on its own. So you can see it here. So they're moving in different areas in terms of defense spending and security spending. You can see many of them up here. Let's look at healthcare. Again, some of this stuff a little bit cut off here, but you can see we're investing in being real robots selling for real money in real companies targeting the healthcare marketplace. And it's not limited to only surgical robots. That typically is where many people are focused on now. So things such as rehabilitation systems with the Locomat. Athon's Tug is a hospital logistics and delivery system out of Pittsburgh. Upper extremity and lower extremity prosthetics now. Some of this funded by defense funding. Others of them are coming through sort of the healthcare field and the National Science Foundation in the US and the equivalent in Europe. So again, real companies making real money. Where are we now with these? There's been a number of major successes in the healthcare field with respect to robotics. Probably the best well-known is Intuitive Surgical in the interventional systems marketplace, surgical systems. But it's not limited to that. So dispensaries in terms of drugs within hospital environments. Again, logistics and delivery systems. Other marketplaces that are doing fairly well, although they're a little bit more rarefied and smaller, rehabilitation robotics, therapeutic robotics. Some of these are even more niched. And again, finally down at the bottom, I've listed some of the things that are just coming out of the labs now. So smart living spaces, a lot of quality of life robotics, teaching systems, educational systems, and the like. So let's look at consumer robotics. Now you notice here, there's many more robots, over 3 million consumer robotics sold last year, but this number is only $750 million, $800 million, not even $1 billion. So they're low-cost robots. There's just a lot of them. They break it down, the IFRs, to domestic entertainment. There's another way to break it down, and this is the way I do it here. Home care, lawn care, which in the US is a $23 billion marketplace. The toy industry worldwide is $83 billion. And robotics now trying to move from the toys trying to move in from the virtual world or even more traditional toys into things like this. Hobby robots. Educational robots is a fairly large marketplace, and then these home care, healthcare, quality of life. These might not be paid for by individuals. They might go through some insurance company or through the government, depending on where you live, for use in the home, however. And then personal robots are on the very cutting edge. This is a robot out of Korea. So where have these things been at this time? Well, basically, the example I use at this time, they just tend to be getting a little bit better. There's not massive breakthroughs on these things. So here's an example of iRobot's Roomba. The next generation of systems added other things. So, for example, you could filter out dust, and they would have HIPAA filters, UV sterilization with a little light. They got better at bumping into things. You could schedule them. Finally, you can automatic docking. So again, it's the same system. It's basically a little mobile robot dragging around a sweeper. But over time, they've just added things. So now they've added cameras to them, a lot of consumer electronics stuff, natural language processing. So that marketplace, it's expected to be the dominant marketplace at some point, but it's not really there yet. And then with educational systems and research systems, I break them down this way: education versus research. And examples of types of robots here. On the right and left-hand side, that's basically cost, and then in complexity. So you can see we've moved up from smart toys to educational robots. And the ones in the middle here are kind of formal learning systems linked in with formal learning structures. Oh, this is cut off. The three classes of research robots here, so they've moved from the past environment to focus on sort of these single robots that you would program, difficult to program. They're adding more autonomy, manipulation, social interaction, groups of robots working cooperatively. Examples of things coming out in the future now. We talked earlier about the Cyberdyne system that's being for some other things that are in the field now. Some are very research-based, like some of the autonomous transportation and some of the field robotics. But those on the left, an oil exploration robot, where they can actually drop the whole exploration outfit and cover the size of a house on the ocean floor, and the robots work inside a sealed environment, so no oil gets leaked out, and they can drill for oil. And then certainly mining robots, mostly used in Australia, but also parts of Asia. These are giant autonomous vehicles, the largest trucks in the world now, with no drivers. An example here is a defense system. This is out of Boston Dynamics. Big Dog, many of you have probably seen this type of film before. Now they follow them. They look a little bit more polished now. I don't know what the advantage of this is over a mule, because now they're trying to find ways where they can actually, well, how do we get energy into it? And it's walking by fields of grass. Robot enablers, robot operating system, cloud robotics, cheap technology, pervasive computing, Moore's law. I'm going to go through this pretty quickly. An example here, a quote by Eric Schmidt, and he's correct about that. What happens when you have unlimited processing power with unlimited network bandwidth, with smart sensors everywhere that are cheap and ubiquitous? So if you look at cell phone uses, basically we're getting to the point where there's going to be more cell phones than people for controls. When you talk about internet connection speeds, again, moving up very quickly. I know I'm going through this fairly quickly here, but I wanted to cover it all. Moore's law, of course. Again, we're kind of cut out a little bit, but you can see the progression here. So again, quicker computation. And then I think it's important to note, COTS technology, just cheap, off-the-shelf technology and componentry that can be used in ways to create very powerful solutions. Here's an example of a LiDAR system built into a Nito robot. This is out of California. So they actually have like a $40 LiDAR system inside the robot. Off to the left is an example of Microsoft's Kinect. Here's two people using an iRobot PackBot. They give the Marines now controllers for games because they're more familiar with that if they're 19 years old. And then, of course, the chipsets, which again keep getting quicker, more powerful, less energy usage, they're more robust. Moves on and on. This is a slide for robot operating system, kind of cut off operating system that can be used both in service robotics, consumer robotics, research robotics, of course, and now moving into the industrial space. So there's work going on for this for years. It needs maybe more of a commercial polish to it, but that's happening. And then areas such as cloud robotics and cloud computing to move down into robotics. So for example, that amount of processing, even no matter how powerful the chipsets and no matter how cheap the processors are, you would have unlimited processing if you bring that up to the cloud and commuting. And of course, the robots can download the latest software, all on the fly. So again, cloud robotics is a big effort underway, particularly in research, and that's moving forward into the commercial space, although tentatively. And here's some examples of robots using cloud robotics functionality. Okay, so what can we expect in the near term? Here's examples. I mean, this is pretty much what is going on now. There's a lot of success, a lot of noise out in the industry at this particular time. You have regional robotics clusters. Robotdalen is one of them, DTI in Denmark is another, Osaka City, Tokyo, Seoul, Boston, Pittsburgh, Silicon Valley, Munich, Paris, probably the major ones, parts of Spain as well, and Italy moving up as well. So again, there's a number of political social drivers pushing this, aging population, baby boomers who have a lot of money and a lot of political clout. There's government initiatives in Europe, in North America finally, outside of defense, and certainly in Asia. So again, a lot of things happening at this particular time. So what about the visionary stuff? Okay, so I've cut out most of this, but when you look at sort of the underlying core capabilities and core technologies, this is where the action is in terms of research right now. This is where people are focusing on the research in the laboratories for the most part. I'm generalizing here, but it's generally true. what they're looking for is certain capabilities, and those are the capabilities, and this is a comparison of European as well as North American as well as Asian research. Again, generalizing, but again, this is where the bulk of the research over the next 5 years is pushing forward. Overarching everything is the notion of autonomy, to give these robots more of an ability to decide for themselves. It's not autonomy in the way that the ancient Greeks meant it, and it's not autonomy like biological systems, but again, it's autonomy where it's robotic autonomy. So it can perform tasks in a certain way. So moving from the area of teleoperation or direct control or direct programmatic control to things such as task autonomy, where you tell the robot to do something and it just does it. And for the last slide, at exactly 20 minutes, is this slide here. And again, I apologize for this being cut off. So when we think of robotics, we tend to think of that middle thing. These are devices and technologies that can sense, they can think or cogitate on that for a bit, and then they act in the physical world. They have actuation involved. That's different than pure automation, where literally you sense something and you act, and there's no decision process being made in there. If you look over to the right-hand side, technology, our phones to the most part, although they're moving down to smart devices. So you can communicate and collaborate with these devices. Very, very powerful. Those same technologies can be incorporated now into robotic systems. So for example, if you look at something called cloud robotics, or you look at these smart devices, they have accelerometers in them. They have software that can recognize faces, natural language processing, language conversion, just a number of things that they can do that you can download into these systems on the fly. So you move over and you get to smart devices, where these things might be able to act in some ways. For example, a smart sensor, communicate, collaborate with other types of sensors in a house or in other or in public places or in workplaces, and then act in that. And then on the left-hand side, we can act, but actually larger in the physical world, and we can act with some degree of autonomy, and maybe even with learning. And that's where we're moving now. Underlying a lot of this now will be data and information, particularly with robotic systems. So all that information, all that data is captured during manufacturing processes or other types of processes, become available for optimizing those processes. So again, we get a much grander vision of what we're talking about when we mean just pure robotics. And in one way, this is where I see this particular marketplace moving at this particular time. It's difficult to taxonomize it, but I've done the best that I can for this particular time. And with that, I think that's 20 minutes. Again, I apologize for the screen being cut out a little bit. If you have any questions, I'll be free to answer them. I'll be here all day. Thank you very much.
Thank you, Dan. Thank you, Dan. And like I said, we will have a short chat shortly along with the other speakers. So I'll ask you to take your seat in the front.